In this video, we will focus on the objects that exhibit periodic behavior. And for this type of situation, we may apply sinusoidal models. We may build sinusoidal model since the functions sine and cosine are the periodic functions. Okay, let's solve exercise number 1. Because of the gravitational attractions of the moon and the sun on the earth, water in seas and oceans tend to rise and fall periodically, corresponding to what is called high and low tides. In a typical situation, the time between two high tides is close to 12 hours. On a particular day in the winter in Boston Port, it was determined that high tide was at midnight, with a water height 9.9 feet. Low tide was determined to be at 6 a.m. with a water height of 0.3 feet. Okay, let's take this scenario and determine the sinusoidal model. Since the situation is repeating every 12 hours, we can see the period is 12 hours, and the model must represent the height of the water hours after midnight. And since we know that the maximum value is actually happening at midnight, we may use the cosine function, because we know that cosine at 0 attains the maximum. So let's start with this. I can draw not so high. We may build the sine function or cosine function, but I will build the cosine function. And we also know that we will shift a little bit because of these values. So I can say this is the maximum, and cosine function, cosine model looks like this. And again, the whole period. Okay, that means this will be the height with respect to time. And I can say that the starting point is 12 a.m. Okay, then 12 a.m. and also at midnight, 12 a.m. of course, the water height attains maximum 9.9 feet. Okay, the low tide, which is minimum, it happens to be at 6 a.m. Okay, and it's 0.3. Okay, really nice. We do have a vertical shift. We don't have horizontal shift for this cosine model. I mean, I can say that I decided to do this. A cosine B T minus C n plus D. We know what are the coefficients, what they means, because I can just switch the slide for a second. You may pause the video and review all of the coefficients. Okay, but we did this and you are confident. Okay, let's come back. One thing, I will also draw the midline. The midline is the line in the middle between the maximum and minimum. We can compute this distance between maximum and minimum, and actually half of this distance is the amplitude, right? This distance from the midline to minimum or from the midline to maximum is the amplitude. Let's actually compute the amplitude. Right? That means we will take 9.9 minus 0.3. Okay, 9.9 minus 0.3, and we will divide by 2. We will have 9.6 divide 9.6 divided by 2, I think is 4.8. Okay, that means we will have a 4.8. This distance is 4.8, and now 0.3 plus 4.8 will give us the midline. The midline, okay, and the midline will indicate the quantity D, because that's normally the midline for cosine function, and for sine is 0, and we shifted that number of units. Okay, 0.3 plus 4.8, I think it's, actually I can use blue also, 5.1. Okay, that means D will be 5.1. 4.8 plus 5.1, because we're shifting everything. Okay, we can also take care of the quantity B. Let's see what we have, and we will finalize part A. Actually, let's see. We know that everything is happening, repeating after 12 hours. Okay. Oh, no. Let's wait. The high tides is typically the time between two. Okay, yes, between two maxima. It's 12. Okay. It means the period is 12. I can use the green color between this and this one. This is 12 hours. 12 hours is the period. Period is not really placed in the model. We have the quantity B, but we know how they are strongly related. Yes, period times the quantity B always is the 2 pi, because for the cosine and sine model, the period is 2 pi. But we can also remember that the quantity B is 2 pi over period. I can't write, which is 12. Pi over 6 is the quantity, the coefficient B. Okay, we may also find sometimes, I always like to do this, I can use this color, because we know that between that maximum and the midline and minimum, and again the midline and the maximum, between the time intervals along the T, the x-axis, it's always a quarter of the period. 12 hours, a quarter of 12 is 3 hours. So let's see if we correct. Midnight, and then 3 hours. 3 a.m., 6 a.m., perfect. 9 a.m., and midday. Okay, we good. Everything works. Yeah, PM, yes, because we don't want to make the mistake. It's not 24 hours. Okay, that's okay. Everything works, and we have to find this model T hours after midnight. But as I said, at midnight is exactly the maximum. That we do not shift to the right or left. Then the coefficient C is basically 0. I can remove it completely. Or I can say the height is represented by the cosine function 4.8 cosine of pi over 6t plus the vertical shift 5.1 midline. Okay, we do have a model. Excellent. Now we have to figure out part B, when to launch the boat. Okay. To launch your boat from this port, you need the water height to be at least 7.5 feet. Okay, 7.5. Determine the time intervals during the day. Okay, that means we might move our, because it's periodic situation, every 12 hours, so that's maybe we may add 12 to our solution during the day when you will be able to launch your boat. Okay, I can use this, where is 7, I can remove that label for amplitude. Let's say 7.5. When I draw the line, okay, this will be the time and this. But we may guess this time will be the night. Yeah, like I can guess like maybe 1 hour before 3 a.m., maybe 2. Okay, I don't know what we will see, but I definitely have to add 12 hours to reach the time during the day. It means I will add another situation. I mean another curve. That means we will probably looking for that time. That means let me this time T sub 1 and then T sub 2. We need that and this time. And this one will be, of course, another 3 hours, 12 p.m. This will be 3 p.m. or 15 if we use the military time. Right, that's mean we will need that only that time interval, because this will be 7.5 or above. Yeah, 7.5 height or above. I mean, this will be the time interval corresponds. Let's find this. We have to set up our equation. Part B will be this equation. The height must be 7.5 feet or above. Of course. I mean, let's solve this equation. I will move everything on the other side. Part B, 4.8 cosine of pi over 6t plus the shift 5.1 must be 7.5. Height must be 7.5. Okay, let's isolate cosine first. That means I will subtract. Okay, let me write this. Cosine of pi over 6t, and we subtracting 5.1, 2.4, and dividing by 4.8, both sides of the equation, we will get cosine pi over 6t, 2.4 divided by 4.8, it is 1/2. Good number. Yeah, that's good number. Okay, that's when we have nice equation. Cosine for what angle equals to 1/2. We know that the angle is pi over 3, 60 degrees. But what we do have the solution theoretically from the first quadrant and the fourth quadrant. But of course, we have to be careful if we're using negative notation or positive. Okay, that means angle pi over 60 equals to pi over 3. Yes, pi over 3, or the angle pi, because I have to copy this, pi over 60 equals to, because from the fourth quadrant, depends, I can say, let's say 5 pi over 3, yeah, because that's the angle from the fourth quadrant. I can also use negative pi over 3. That will be still fine, yeah, using the negative notation. And we also know that everything is repeated, yeah, plus 12 hours times n. Yes, 12 hours times n, which means 12n. Actually, I can even change that. I don't have to 12 hours times 1, 12 hours times 2 and 3. Okay, but let's solve this for t. I can ignore the 12 hours for a second. Solving this equation for t, because we have to get back to our model, we will divide both sides by pi over 6, multiplying by 6 over pi. This is 2. It sounds like 2 a.m. We will see where we are in a minute. And when I divide both sides by pi over 6, multiplying by the reciprocal, we will get, what we will get? Pi will be cancelled out. This will be 2 times 5, 10. Okay, let's say 10 a.m. Okay, but we will see, maybe 10 p.m. because depends if I'm adding or subtracting. Let's check where we are. Where is 2 a.m.? 2 a.m. Oh, okay, 2 a.m. looks like here, 2 a.m. But we definitely need time. We can add 12. It will be 2 p.m. because 12 hours. Yeah, that means when we go, that will be when we adding 12. Oh, wait a minute. Where we are. Oh yeah, makes sense. 2 p.m. Yes, 2 p.m. because I would like to jump one period. I would like to have the time during the day, not during the night. And the other solution, that's when we are good with this one. This one actually when we add, yeah, because we can adjust, it's not a problem. We know where we are on the periodic model. 10 a.m. And actually 10 a.m. makes sense, 10 a.m. It means only between 10 a.m. and 2 p.m. we can get, yes, we can use our boat because the height of the water will be 7.5 or higher, at least 7.5. Okay, it's really nice question. You may try to do this on your own. You may erase this, or you may pause the video before the solution is provided and solve it. Let's do one more, and then you will practice your sinusoidal models. Okay, I have this. A particular person's height oscillates throughout the day with a period of 24 hours. The average height is 170 centimeters, and the maximum height is 173 centimeters. At 4 a.m., the height is 170 and increasing. Okay, this is suggesting the model. We will see. Find the possible formula for h of t, the height in centimeters, t hours after midnight, and find a time when the height equals to 169. Okay, so first of all, I will do, we have the average. Average, of course, is the midline. We do have the maximum, and it's telling us that 4 a.m., the height is actually average, the midline. Okay. And since the values are not between -1 and 1, like for sine and cosine, then we definitely have a vertical shift. And probably we have a horizontal shift also, because 4 a.m. I mean, I will start with the sine function, sine model. Okay, that means sine, because it's telling us that we have average. We know how sine function behaves. Let me draw maybe. It's like this. I will erase this. And that's the average, because this is the midline. Yeah, that's the midline for sine function. And from that average is increasing. I mean, that's what's suggesting. But we will shift everything. Yeah, that's mean I will, it's increasing. But also that dot, it's happening at 4 a.m. because we're assuming that this is a midnight. 0 is a midnight. I mean, I will shift also. Okay. I will shift everything for, that means this will be 4 a.m. And then sine model. One part, and another. Am I not really symmetric? We can see. Okay, let's leave it. We never have a perfect circle. We never have a perfect, but we know the model. Time, height. Because you have to have a perfect solution. Okay. So we know that this average is 170. That's the height. Okay, midline. We have one of the coefficient. That's the midline. Now what we know, maximum height, which is happening here, it's 173. We know the amplitude. Yes, we can see the amplitude is just 3 centimeters. Okay, let me put the model. H of t will be defined as A sine B t minus c plus d. We know all of the coefficients. Let's build up. A is 3. Period is 24. I can put right away 2 pi over 24. And then I need C, the horizontal shift, and D, the midline, the blue line, is shifted from 0 to the level 170. And actually, C, we can see we just moved everything to the 4 a.m. because that was the initial point for the sine function. Right? That means we moved 170 up and 4 hours to the right. Okay, we have everything. 2 pi over 24, of course, can be simplified to pi over 12. So easy, so easy model. Okay, really nice. Let's put some times because we will know where we are so fast, almost done. Yeah? You will be an expert with sinusoidal model. Okay, when we have 24 hours period, I can write this, period is 24 hours. We need quarters. Yeah? Quarters, of course, is 6 hours. That means we will say this is happening at 10 a.m. and then this is 16 we know that 60, let me put 16. Then I don't need, or maybe 4. We will adjust. Oh, actually, let's use the military time. Okay, we will be less confused. 16 and then 22. 22 is of course 10 o'clock. And oh, we will not have, it will be 28. Really funny. That's actually not good. But probably 24 is somewhere here. And then this will be 4 hours. That's 4 hours after midnight. 4 a.m. again. I mean, this corresponds to the 4 a.m. That's not good. Okay, but I just, because it's periodic, I can keep these big numbers, but we know what they means with respect to the time. Okay, we have the model. Definitely we have the model. Actually, let me put pi over 12. Yes, we know how to, I will put pi over 12, and we computing b 2 pi, always 2 pi over the given period. That's the number confirmed. Okay, now we have to find out the time when the height is 169. Okay, where is 169? Oh, 169 is here. Let's see the intersection. We will need that time, t sub 1. Oh, almost 24. Oh, possibly. Probably my 24 is not in the right place. Oh, that's exact. 24 is not, I don't know. Okay, we will adjust. T sub 2. Let's find this time. Okay, where exactly is, we need that purple dot and that purple dot on the x-axis. Okay, what we need to set up, part B, we want our height to be 169. We do have an equation. Let's solve it. Let's solve it. What I can do, I have this. That's what was the model, was 3 sine of pi over 12, t minus 4, yes, 4 a.m., and plus 170 equals to 169. Because this is the height, equals to 169. Okay, we will subtract 170. When we subtract 170, we will have negative 1 on this side. Having negative 1, let's do this. Okay, 169 minus 70. And then we will divide everything by 3. When we divide by 3, okay, I can copy this. Negative 1/3. Okay, so now we have sine negative. Sine is negative in the 3rd and the 4th quadrant. So we will say sine for what angle is negative 1/3? The angle, that's the entire formula, is equal to inverse sine of negative 1/3. That's the one solution. And always the second solution, yes, always the second solution is that angle. And then we have to say pi. We have to, because we have to be in the pi minus. Yeah, always pi minus inverse sine of this, because the thing is, if the angle is positive, but we can see we will have negative, then if this value is negative, because sine function is odd function, then we are in the 4th quadrant, and if this is negative, we will be adding value, then we are jumping to the 3rd quadrant. Okay, that's in 4th and 3rd. Let's say 4th and 3rd, theoretically, because we will adjust to our model. Okay, now let's solve this equation for t. What we can do, we can, first of all, we can multiply, yes, we can multiply both sides by the reciprocal, 12 over pi. Inverse sine of negative 1/3, and then add 4. 4 plus 12 over pi inverse sine of negative 1/3. And the situation, we will see where we are, repeats every 24 hours, 24 times n, 24 times 1, and then another 24 times 2, and so on. Okay, and 1 second, because I will, and the same for this one, we will multiply, and write for you, everything by 12 over pi, the entire both side, sine, and then we will add 4, 12 over pi, and then pi minus inverse sine of negative 1/3. Okay, and when we use calculator, of course, we can add 24. When we use the calculator, and I think we found this, let me, when we use the calculator, yes, we will get the number, and I use the calculator, I typed everything, and I got 26.7. Okay, that's mean 26.7, and let's see, and this one, I use the calculator, and I've got 17.3. Okay, that means 17.3. It's 17 is the 5 o'clock, 17. Yeah? 5 o'clock and 0.3 of the hour is 20 minutes. That means this one, I would say, where we are, this one is 5:20 p.m. Okay, this one is 2 hours after midnight, and 0.7 of the hours. 0.7 of the hours is like 42 minutes. I did calculate this. You can also check. 0.7 of 60 minutes will be 42, of course. 2:42 a.m. Okay, that's where we are. We have to probably, to that 2 a.m., we have to add 24 hours. Which actually it gave us this, yeah, this time. No, let's check where we are, what I have to do. Where am I? 5, this is 16, okay, that means this is 16, which is 4 p.m. and we've got the time 5 p.m. That means this one is 5:20. 5:20, perfect. That's the time. And this one, oh yeah, that actually, okay. This one, this time, what we've got 26.7. Let me think. Okay, it is two. Because it's, yeah, it went, hang on, it's after, that's been the midnight, it's 24, somewhere here. Okay, no, it is a.m. That means it's 2:42 a.m. I just want to be, okay, that's done. 2:42 a.m. Makes sense. Okay, we may see the same thing. Yeah? It will be here, but then we have to, how we can compute it. That will be also, because it's periodic, and we can add or subtract actually 24 hours. Yeah, we can add or subtract 24 hours, and we will get this. But we don't have to 2 point. Oh yeah, 2 point easy. 26.7, it will be 2.7. Yeah, just 2.7, and of course 2.7 is 2 and 2 a.m. and 0.7 of an hour, which is 42 minutes. The same thing. Yeah, this will be the same thing. 2:42 a.m. Yeah, just to have the idea. because it's 24 hours difference. Okay, but what we will need that purple and that purple. Yeah, that means find the time when the height equals to 169 between 5:20 p.m. to 2:42 a.m. p.m. Okay. Thank you, and please enjoy these two problems. I really encourage everybody to cover the solutions and try to solve it from the scratch. Thank you.